Welcome back. In this video, we're going to continue learning about solutions, and specifically, we're going to focus on electrolytes. We'll start by defining what an electrolyte is and distinguishing between strong, weak, and non-electrolytes. And then we'll describe the dissociation process for electrolytes, non-electrolytes, and talk about the substances that you need to be able to identify as acids, bases, and salts. So what is an electrolyte? An electrolyte is a substance that can dissociate when it's placed into water, and therefore it conducts electricity. We can have strong electrolytes or weak electrolytes. A strong electrolyte is a substance that will dissociate completely in water. A weak electrolyte will dissociate only to a very limited extent, and typically this is less than 1%. Finally, we have substances that are non-electrolytes, and they don't dissociate at all. In a previous video, we looked at sugar in water, how sugar does dissolve in water, but it doesn't dissociate. Therefore, sugar is an example of a non-electrolyte. To be able to identify strong electrolytes, you need to be able to recognize what is a salt. A salt is a combination of a metal and a non-metal. Salts are ionic compounds. Therefore, all salts are strong electrolytes. Additionally, you need to be able to identify the strong bases and the strong acids. The strong bases are combinations of hydroxides with group 1A and 2A metals. So these are also ionic compounds. However, they fall under a special category that we call bases. And so again, these are metals that are combined with hydroxide. And it's metals of group 1A and 2A, with the exception of magnesium hydroxide and beryllium hydroxide. Those are bases, however, they are weak bases. Therefore, they would be counted as weak electrolytes. There are 7 strong acids that you need to be familiar with: hydrochloric acid, hydrobromic acid, hydroiodic acid, perchloric acid, chloric acid, nitric acid, and sulfuric acid. Again, so for strong electrolytes, you have all of your salts, the 8 strong bases, and the 7 strong acids. For weak electrolytes, this includes weak bases and weak acids, which includes your carboxylic acids and amines. And essentially, if it's an acid or a base, but it's not on your list of strong acids or bases, it must be a weak electrolyte. Finally, we have our non-electrolytes, which don't dissociate at all, and this includes everything else. To review, when we look at the dissolution process, we see a different process that occurs for ionic compounds, where they will dissociate in water, but most molecular compounds do not. Now, the important caveat here is that your strong acids are molecular compounds, but they do dissociate fully. So let's take another look at identifying acids, bases, and non-electrolytes. For acids, there are 2 types of acids that you'll be expected to recognize. There are acids that begin with an H in its formula, such as hydrofluoric acid, hydroiodic acid, sulfuric acid, and in this case, some of them are strong and some of them are weak. Our 7 strong acids fall under this category. You also then have carboxylic acids, and they have the functional group that's the carboxylic acid. For Chem 110, all of these will be considered weak. For the bases, there's 2 types of bases, just as there are 2 types of acids. There's the bases that involve metal hydroxides. Some of those are strong, and some of those are weak. And then our amines, and all of those are weak. And then again, for our non-electrolytes, these include all other functional groups. There's a flow chart that you can find in the ebook that's very useful for determining whether or not a substance is a strong or weak electrolyte. The first question in this flow chart is to identify whether or not the compound is ionic or molecular. If it's ionic, it's going to be a strong electrolyte. And notice that this includes within here our strong acids. Our strong acids, the metal hydroxides, excuse me, this is our strong bases. Our metal hydroxides, strong bases, are ionic. If it's not ionic, then it will be molecular. And then you want to ask, is it an acid, a base, or neither of those? If it's a base, then it's a weak base and it's a weak electrolyte. If it's neither acid nor base, then it's a non-electrolyte. Within the acids, you need to identify, is it a strong or a weak acid? If it's a strong acid, it's a strong electrolyte. And if it's a weak acid, it's a weak electrolyte. So let's practice here. I'd like for you to pause the video and try to identify which of those substances would be classified as weak electrolytes in an aqueous solution. Welcome back. So in order to do this, you need to have memorized your list of strong acids and strong bases and be able to recognize whether or not other substances are acids or bases based on the functional groups involved, and as well if they are ionic compounds. So let's go through each one of these. The first substance is going to be a strong acid. If we're following the flow chart, for this first substance, we identify that it is molecular, that it is an acid, and that it's one of our strong acids. For the second substance, you should be able to identify this as molecular because it's only consisting of metals and nonmetals. However, this is a base. This is an amine. Therefore, it's a weak base. For glucose, we should recognize this as molecular, but as neither acid nor base. This is a non-electrolyte. Barium hydroxide, you should be able to recognize both as an ionic compound as well as one of our strong bases. Potassium azide, you should recognize that this has a metal with nonmetal. Therefore, this is an ionic compound and a salt. Ammonium bromide is a little bit harder. You perhaps thought that this would be a molecular compound because you only saw nonmetals. However, you need to remember that ammonium is a cation, and therefore it behaves as a metal and forms ionic compounds. HF, this you should recognize as a molecular compound and as an acid because it starts with H. However, it's not on our list of strong acids, therefore it's a weak electrolyte, a weak acid. H3PO4, we also recognize as molecular, as an acid because it starts with hydrogen, and as a weak acid. It's not on our list of strong acids. Finally, this last compound you should be able to recognize as molecular because it only has nonmetals involved. However, this is not a base. The only bases that have hydroxide in them are the metal hydroxides. Most of those are strong bases. Magnesium and beryllium hydroxide are the weak bases you need to be familiar with. This, however, is an alcohol, which is an example of a non-electrolyte. That's it for this video. Thanks for watching. Have a great day.